Hello and welcome. So we're going to be factoring the following expression completely, if possible. Now, the first thing to check for with factoring is a GCF, which we don't have one here, so moving on. The next thing would be to double check your number of terms, which usually tells you how to factor. Now, here we have 4 terms, which generally says factoring by grouping, which is a split down the middle. Look at your first 2 and your last 2 terms for GCFs of the 2. You can notice there's at least a GCF of 2. They're both even numbers in this first one. You also have a GCF of W. Yay! Right, so 2W is minimum there. There could be a larger one. Now, of your last 2 terms, however, there is nothing in common between those. So, bummer. Now, factoring by grouping would generally say keep rearranging the terms until it doesn't work. I'm just going to put a spoiler in here. Rearranging isn't going to help us with this. All right, so then we'd say, okay, well, how am I going to factor this? A factor by grouping is not an option. Well, take a look at some of the numbers we have in here. We have 144, 25, and 121. All right, also look at the variables attached to these. Everything here is a perfect square. The perfect square of your first term is 12w. If I were to take that and square it, you get 144w squared. Same thing here, I have 5n. Is the number you would have to, not the n, you would have to square in order to get 25n squared. Same thing here, 11b would be your number to square in order to get 121b squared. There's a lot of perfect squares here. So then I'd say, okay, let's look at some of our polynomial identities that work with perfect squares. There's a couple of them. You have your perfect square trinomials, right? So we have a plus b squared equals a squared plus 2ab plus b squared is going to be that one. Now that plus minus is indicating if it's a plus, it will be a plus there in our equation. If it's a minus, it'll be a minus, nothing too crazy. And then our other perfect square identity is going to deal with our difference of squares, right? If you have a minus b and a plus b multiplied, it's called a difference of squares there. That's going to be your a squared minus b squared. Okay, so when I'm looking at that, I'd say, all right, well, when I'm first looking at this, we have a lot more than just 2 things, right? We have 4 things. But I'm going to break this down. I'm going to say, okay, what if I just look at the first 3 things on their own? If I look at just these, do I have my perfect square trinomial? An answer? Yes, because if I'm looking at this, I'd say, okay, so perfect square, which is 12w squared, perfect square, which is our 5n, right? And then we have our middle term, which is the product of our first 2 perfect squares, so 12w times 5n, and then that has to be doubled. And we're going to say, is that the same as what we have there? Well, 12 times 5, 60 times 2, 120, and then wn multiplied is just wn. Booyah! Ding ding! Right? They match. Okay, the sign I'm not going to look at too deeply because honestly the plus minus is not going to make a difference. It'll just tell you what's in the parenthesis. We're just saying if we get the same numeric value as the middle term there when we multiply. So it matches. Yay! That tells you that perfect square trinomial is what we're going to be doing here. So that means we have our first perfect square, 12w, our second perfect square, 5n, and the sign in the middle is a minus, so we'll just use minus here, squared, minus our 121b squared. Our second term, right, our minus 121b squared, that hasn't changed, it hasn't done anything, it's just tacked on behind. All right, so then I say, great, now we have first term minus second term. All right, we have factored the first 3 into one thing together. So I'd say, great, now what do I do? Because my goal for factoring, right, is just parentheses being multiplied, no other addition or subtraction, right? So this continues to factor. And then you might be wondering, how? Well, keep in mind, you have 2 terms. You have 2 terms that are squared, meaning that you have a difference of squares here, right? We have 2 squares with subtraction between them. Your first square is the 12w minus 5n. Your second square is the 121b, all right, which means, oh, my apologies, almost made a mistake there. That is 11b. So our second square is 11b. Okay, same thing. Your first perfect square, 12w minus 5n. Your second perfect square, 11b. And then from there, the identity says that when you have those two perfect squares being subtracted, then you can write them out separately with addition and subtraction. It feels a little weird because you have two terms inside your first perfect square, but that is actually a totally valid identity use because this is the same thing twice, right? It's 12w minus 5n squared. Expressions can be perfect squares as well. So there's your first perfect square all together. Now, would I put in those orange parentheses? No. My true answer would actually, honestly, just be that. It'd be 12w minus 5n plus 11b. And 12 minus 5n, whoops, keep forgetting my variables today, minus or plus 11b. Essentially, this thing, I'm having a harder time writing it smaller. There you go. Thanks for watching.